Alright, so in this video we're going to be solving the LeetCode daily problem for 1 to 98, which is maximum candies you can get from boxes. So this is marked as a hard level problem, but once you understand the problem, you would basically find it to be a medium level problem. So let's get right into the problem statement. So you have n boxes labeled from 0 to n minus 1. You are given 4 arrays, status, candies, keys, and contained boxes, where status of I is 1 if the ith box is open and 0 if the ith box is closed. Candies of I is the number of candies in the ith box. Keys of I is a list of the labels of the boxes that you can open after opening the ith box, and contained boxes of I is a list of the boxes you found inside the ith box. So this is basically the description of the boxes and the arrays that have been given to us, or the vectors. So let me show you on the sketchpad, basically, and copy this, paste it here, right. So as you can see, we have all these vector of n type. Candies is vector of n type. Keys is vector of n type, and contained boxes is also vector of n type, and initial boxes is just a vector of int, right? So now we see basically what the problem is asking us to do is you are given an integer array initial boxes that contains the label of boxes that you initially have. Now you can take all the candies in any open box and you can use the keys in it to open new boxes, and you can also use the boxes you find in it, right? So return the maximum number of candies you can get by following the rules here. Okay, so now let's get into the example part. So initial boxes is given to us as 0, right? And let me mark using the pen. So you have 0, 1, 2, and 3. These are the indices. So basically we have 4 boxes labeled 0, 1, 2, 3, and the candies respectively placed in the boxes labeled 0 to 3 are 7, 5, 4, and 100. And for the keys, we have in the 0th box we have no key present. In the first box also we have no key present. In the second box we have a key present to open the box 1, and for the third index also we have no key present here. So this is the information that we got until here. Then contained boxes is basically the you may have seen the Russian dolls that there are Russian dolls, right? Let me show you Russian dolls. So Russian dolls basically are known as the Matryoshka dolls. So they're basically dolls present within another doll, right? So you can open one doll, a bigger doll, and you see another smaller doll present in it, and it happens like this. So basically in the problem as well, it's also given that you have a box within a box, so a larger box within a smaller box. It may not be large or small, we cannot decide that because that's not mentioned, but these are the contained boxes. So in the 0th box, we also have the boxes labeled 1 and 2. In the first box, we have the box labeled 3, and in the other two, we don't have any. So basically, what this means is, I'll draw a visual representation. The 0th box is given like this. So this is the 0th box. In the 0th box, you have contained boxes 1 and 2. So the labels 1 and 2 you have. These are the 1 and 2 boxes. And in the box labeled 1, so this is 1 actually. So this, let me just draw it in proportion. So this one actually contains 3 also. So a smaller, box which is 3 here, right? And you can see keys in all the other boxes. There are no keys except for the second box labeled second. So in this box, you have a key. And the key is for opening, this is the key, and this key is for opening the box number 1. You understand? So this is basically the visual representation. So now let's get back to the problem, and you will notice in the 0th index box you have 7 candies, so there will be 7 candies here present. Okay, so there will be 7 candies in this. Then in the box number 1 you will have 5. So in this box you have 5. In the second box you have 4 candies, and in the third box you have 100 candies. So obviously the size and all that does not match, but that's not relevant for the problem. We're not considering the dimensions and stuff, but we just need to get the crux of the problem. And the status basically represents whether the box is open or locked, right? So this box, the one index 0, it is open. The status of box number 1 is 0, which means that this box is closed. That is why we need a key for that. And therefore, the second box is open. So if the second box is open, we can get the candies from the 0th and the second boxes. So initially we check for 0th and second box that we can have 7 and 4 candies from these two. So this is the 0th index and this is the second index. And since we have visited the second also, we see that it has the key for opening the box number 1. So this is the box number 1, which contains 5 candies. So once we visited second, we can get the key for 1, and once we open 1, we can get the candies from 1, which are 5 in number. So we take that as well, and this is index 1. And basically we cannot open the box number 3 because we haven't been given, it is closed and we haven't been given any key for opening 3. So that basically is our final answer, which is 12 plus 4, which is 16. So we get total 16 candies, and this is the maximum number of candies that we need to return. So now I hope you understood the problem, and yeah, you can see 16 is the number of candies that will be returned. Similarly, you can go over example 2, and in the next video I'm going to be talking about the solution.